Alright, let's look at an optimization problem. You are under contract to design a storage building with a square base and a volume of 14,000 cubic feet. The cost of materials is $4 per square foot for the floor, $16 per square foot for the walls, and $3 per square foot for the roof. Find the dimensions that minimize the cost of materials. So the key here, the key sentence is to find the dimensions that minimize the cost of materials. So we want to minimize the cost of materials. So here I already drew my box or my storage building. So they say the storage building will have a square base. So a square base just means that the length and the width have the same, the same size. So we will label that x and x, and then it has a certain value h as its height. So what we gotta do first here, we need to write the equation for the cost of materials because that's what we need to minimize. And this brings us back to algebra, how to set up the equation of costs, and they give you patati patata, and you have to be able to write the equation of cost. So what do we know here? We are facing, we are dealing with a cube, right? A cube where they give us the volume to be equal to 14,000 cubic feet, right? And they tell us that we have $4 per square feet for the floor, $16 for the walls, and $3 for the roof. These are all important pieces of information. So the first thing we gotta do here, how many floors do we have? We only have one floor. And the cost here is based on the square foot. So that means that we need to calculate the surface of the floor. To calculate the surface of the floor, it's gonna be length times width. So it's gonna be x times x, which equals to x squared. So to get the total cost of the floor, it's just gonna be 4 times x squared, right? Because we gotta get the value, the price, we multiply by the area, it's gonna give us the cost. Next here, we're looking at the wall. How many walls do we have? We have 4 walls, right? On each side, front, back, left, and right. So it's already 4 sides. And then we gotta multiply that by the area. What is the area of the side? The area of the side here, we have the length times width, so it's gonna be that x times h, right? And then we multiply that by the value of 16, which is the price. So we have the price here, and then this is the area for each wall times 4, and then that will give us the total cost for the walls. And last we have the roof that is costing $3 per area, and then we only have one roof, which is the top here, and the area of the roof will be the same as the area of the floor, right? So that would be just x squared because we have x here and x. So then we'll multiply that by 3, so it's going to be 3x squared. And to write this entire equation, basically we are summing all these costs that will give us the total cost of the materials. So that will be 4x squared plus 3x squared. All right, 16 times 4 will give 64xh, and I say that is equal just to a certain c that I label as the cost, right? So from here I can quickly simplify or combine like terms. We have x squared and x squared, so it's going to be 7x squared, and then 64xh equals to c. So before I go any further, I know that that's just the first equation that I drew. I'm gonna see if there's any other equation that I can write so that I can combine them before I proceed into minimizing this equation of cost. What have we not used yet? So we've used these three elements here, but we haven't used this information related to the volume. What is the volume of a cube? It's going to be the length times width times height. But we know that the length and width are the same because the base is squared, so it's going to be x times x, which is just x squared. Then we multiply that by the height. Right, x times h, that's the volume. We know this entire expression will equal to 14,000 as we have provided here. And then from here, what I'm gonna say, alright, I can solve for h. Why do I want to solve for h? Because it's gonna give me an expression of h in terms of x. Then I can take that and substitute over here. That way I'll have the equation of costs that has only one unknown, because currently it has two unknowns, the x and the h. So from here, if I solve for h, means I'll divide by x squared to leave h alone, so it's going to be 14,000 divided by x squared, right? And then this is the expression of h that I want to plug it into that first equation that I had, and that will yield 7x squared plus 64x times 14,000 divided by x squared, and that's equal to C. And I can just rearrange this equation, and by rearranging, what do I get? I get 7x squared plus, I'm gonna multiply the 64 times the 14,000, and that should be equal to 1, 2, 3, and I cancel 1x here with the square, so it's gonna leave only 1x in the bottom, and that equals to C. So then this is the expression of the cost of materials in terms of only one unknown, that is x. So from here, in order for us to minimize the dimension, to minimize the cost of materials, we gotta take the derivative of this and set that equal to 0. So let's go ahead and do that. We're doing the derivative with respect to the length. So over here, the first derivative of this one will be 14x, and then the derivative of the second one is going to be negative 896,000 divided by x squared, right? That is just straight derivative. So, you know, if that one doesn't make sense, go and review the properties of derivatives. That way you know how to do that. And then from there we set this equation equals to 0. So it's 14x minus 896,000 divided by x squared equals to 0. Then I multiply everything by x squared to get rid of the x squared on the bottom. I multiply this by x squared. So that's gonna be 14x to the third minus 896,000 equals to 0. And I'm trying to solve for x, so it's gonna be x cubed equals to 896,000. I divide that by 14, and from there, if I divide these, I expect to get 64,000. To solve for x, it's gonna be the cubic root of 64,000, which is equal to 40. Since this is the distance and the unit we've been dealing with is foot, so it's gonna be 40 feet for x. So now that we know the value of x, we need to find the value of h. So we already have gotten the expression of h here in terms of x, so we can just plug the x there to solve for h. So do 14,000, then you divide that by the value you just found of 40, and you square it. It's gonna be 14,000 divided by 1600. And if you go ahead and do the division here, or you use your calculator, you should be able to get 8.75 feet. So as far as your dimension, those are your dimension. Have 8 x of 40 feet, x 40 feet, and h of 8.75 feet. Those are your dimension in order to minimize the cost. Thank you.